All right, today we are in section 3.1, Algebraic Expressions, and we're kind of breaking the ice today, okay, if you will. We're breaking the ice on expressions, like terms, coefficients. This is something, if you were in 6th grade with us last year, you did learn in your 6th grade curriculum last year. So there's some important terms and definitions here. Okay, the first one is the commutative property. This is not the first time you've heard me talk about the commutative property, okay? But this is going to be very, very important in this unit, okay? That you can rearrange expressions so you can match your like terms together. But you always keep the sign in front of the term. So if there was a minus sign in front of the term, you got to keep it there because that makes the term negative. Terms are separated by operations. Plus, minus, multiply, divide, okay? That's what separates each term. It could have exponents, it could have coefficients, variables, but the operations separate them. Like terms have the same variable, okay? So not just a variable, but they have to have the same variable or just a number by itself. All right, I'm going to give you a term for just a number by itself. We call them constants. Okay? So let's take the number 5. Okay? Well, 5 is a constant. It is, that value never changes. Nothing will ever affect the value of 5. Okay? So that's why a number by itself is called a constant. Simplest form. All right? We have to fight the urge to come to an answer. Okay, in this chapter, you won't have one definitive answer. All right, we're going to simplify as much as we can, and then that's it. All right, we just leave it. Okay, then we have a coefficient. That is the number connected to a variable in a term. If there's no variable, there's no coefficient. For example, 3x. Okay, the 3 is the coefficient. It's the number that's connected to a variable in a term, okay? That's a coefficient. All right. Okay, so in example 1, we're just going through and identifying the terms. We're not even simplifying anything yet, okay? You guys with me? Everybody following along, huh? Well, apparently I skipped one of mine. That's okay. Wait. Give me one sec. All right, so terms we're going to separate with commas, okay? So remember, the operations separate the terms, but each term has a sign, okay? So 9x is positive. 2 is negative because there is a subtraction sign in front of it, okay? Is 7 positive or negative? Positive. It's positive. And then if there's no number in front of the variable, what do I know is understood? All right, hold up a finger to tell me what value it is. All right, number 1. Okay, so this is negative 1x. I would like you to write the negative 1. That just kind of reminds you that it's there. Okay, you don't have to, but it's a good reminder. All right. Okay, now we have like terms. Let's talk about like terms. In order for terms to be like each other, that means there has to be another one like it, okay? So if it's just 1, then there are no like terms, all right? So, yes. So we're going to group them in parentheses to group the like terms together. So is there another term like 9x? Y'all just tell me. It has to also have an x. So negative 1x. Both of those terms have a variable. Both of those terms have an x. Do I have another set of like terms? Yes. Yes. Negative 2 and positive 7. You don't have to write the plus 7. 7 by itself means positive. But these are, what was that C word that we used? They are constants. Constants. Remember, a number, I know I threw you off. Okay, a number by itself is constant because the value is constant. There's nothing changing the negative 2. It is negative 2. Now, coefficients are the number only that's in a variable term. It's just the number, though. It's not the variable. So the coefficient, okay, can only be in a term with the variable. So we have a coefficient of 9 because 9 was the value in front of the x. Do we have another coefficient? Yes. Negative 1. Okay. All right. And then the fourth category is your constants. Okay. Constants would be negative 2 and 7. All right. I guess your book didn't go into that. Did I skip one? Okay. All right. So now I want to take just about a minute to see if you guys can get a little bit ahead of me on this next one. All right. Terms, like terms, and coefficients. Hopefully you're a step or two ahead of me. Okay. So for your terms, you have negative 3x, 7, 10, and negative 5x. Whoops, forgot my x. Okay, so someone raise your hand and give me one set of like terms. Zoe?
Negative 3x and negative 5x.
Perfect, and negative 5x. Someone raise your hand and give me another set of like terms. Cadence? 7 and 10. Very good. Okay, so now for your coefficients, Hudson?
3 and 5.
No. Haley? Negative 3 and negative 5. Got to make sure you bring those signs out. Okay, you just didn't say it. Yeah. Okay, so just make sure you keep those negatives if it's negative. Okay, now what do you notice that's different about the next one? What do you notice here? Just tell me. There's some exponents. Okay, so we need to clarify something here. The exponents matter when it comes to like terms. Do they all have a z? Yes, they all have a z, but the exponents also have to be the same for them to be like terms, okay? So our terms, we can just list them. Z squared, 5z, make sure your z's don't look like 2's, negative 3z squared, and z, okay? For them to be like terms, however, they have to have the same exponent. So is there another term that also has an exponent of 2? We have z squared. What would be its like term? Negative 3z squared. Don't forget that. Okay. Destiny, do we have another set of like terms?
5z and 1z.
Very good. 5z. And I like that she said 1z. Okay. That's really going to help you guys when we start to simplify. All right. Okay. So now I want you to look. Okay. And I want you to hold up how many fingers on your hand. How many coefficients are in this expression? All right. Hold them up. Okay. What do you guys think? Are there 2 or 4? And like one of these doesn't count. Like you gotta, there are 4. Okay, that's okay. That's all right. There are 4. Because guys, it doesn't matter what the exponent is. Each one of these terms has a variable. Okay, so each one of the numbers in front of the variable are coefficients. So it doesn't matter that we have exponents in there, and it doesn't matter that they're not all like terms. All right, so let's say our coefficients together. 1, 5, negative 3, 1. Okay. I'm sorry? It is not. Okay, that's a good question. It is only the number in front of the variable. So even though there was an exponent that was a number, that's not part of the coefficient. Okay, it's only the number in front of the variable. Good question. Okay, good question. All right, so here we go on our terms on the next one. All right, let's list them together if y'all can say them with me. 7 3/4 p, negative 5, 1 p, 2 q. And hopefully you're writing them kind of as we're saying them. So now let's talk like terms. Remember, in order for terms to be like each other, you have to have at least two of them, okay? You can't say something is like something else if you're not comparing it to anything else, okay? Does anybody think they know one of the sets of like terms? Halen?
3/4 P and 1 P.
Yes, very good. 3/4 P and 1 P. They both have the variable P. All right, does anybody think they know another set? Abby? 7 and -5. But wait, nobody's said anything about 2Q yet. There's no like term to combine it with, okay? So there's nothing to combine it. So if I were simplifying this, I would just simply bring down 2Q because there's nothing to combine it with. Kyrie?
How is it the same if it's negative and positive?
So there's still numbers though. So think back to our last unit. Could you have done 7 plus -5 or 7 minus 5? You can combine that. Okay, so even though they're positive and negative, we know that we can still combine them. All right, coefficients. Someone raise your hand and give me a coefficient. I'm looking for all participation. Mikhail.
3/4 P.
Just 3/4. Okay, so the P gets left off. It's only the number part. All right, Haley?
1.
And 1. Okay, so don't put the variable in when I specifically ask for a coefficient. It's only the number part. All right, any questions? Dylan?
Isn't 2 a coefficient?
Yes, 2 is a coefficient. Good point. All right, I was only looking at my like term set. Good eye. Was anybody else thinking that?
Why didn't you get 7?
right. Now, 7 is not a coefficient. It's a constant. It has to be with a variable to be a coefficient. All right. Forgot poor 2Q up there. All right. Any other questions? Good question. Okay. We're just moving right along. Okay. So now, okay, we're going to kind of piggyback. So what's a piggyback? It's when you jump on top of, right, someone's back and they give you a piggyback ride. Okay. These days, my husband does a lot of those with our little kids. They think it's like the coolest thing ever, and we can motivate them to brush their teeth better. Okay? Piggyback rides to the bathroom to brush teeth. Okay? So piggyback, all right, is what we're doing right now with what we just learned in Unit 1. Okay? Where this is the perfect segue for our song. Okay? So here we go. Same sign, add and keep, different sign, subtract. Take the sign of the larger number, then you'll be exact, okay? So now we're just putting a variable in there, okay? So to combine this, do we have like terms? Do the terms have the same variable? Yes. So now I'm going to look and see, do they have same sign or different? Different. 6 is positive. 6 is positive. 10 is negative. Look. 10 is negative. So is this same sign or different? Different. So subtract, what's 10 minus 6? And take the sign of the larger number. -4, and then bring down your common variable. -4n. You can't solve this because you don't know what n equals.
Just -4 times 1.
Not times 1 because you don't know what n equals. Okay, let's look at the next one. All right, -8b plus 6b plus, wait a second, is there a value in front of that third b?
So it's 1.
It is, oh, yes, there is a value and it's 1, okay? So here's where commutative property can kind of come into play. And remember, commutative property is not mandatory, okay, to get to your answer. However, it can make getting to your answer a little easier, okay? So what do you think would be the easiest to combine first? 6b and 1b. What's 6b plus 1b? 7b. Okay, so -8b plus 7b. Well, you say, well, Ms. Kinder, I thought it was just as easy to do -8 plus 6 and get -2. You can do that also, okay? So commutative property just allows us to kind of mentally switch around the terms if we want to. All right. I think it's easier to do negative 8 plus 7. What's negative 8 plus 7?
Negative 1.
Why would you say negative 1?
Because it's 8 is larger.
Okay. Different signs. Does everybody recognize they were different signs? One was positive, one was negative. Subtract and take the sign of the larger number. Negative 1b, or you could just say negative b. All right, negative 1b or just negative b. All right, any questions so far? How are we doing, guys? Do you guys remember something similar to this from last year? Okay. All right, look at the next one. Don't say anything. Just look at it. See if you can figure out the answer. Anybody see anything? Kyrie?
The 4 and the negative 4 because you could cancel them out.
Yes. 4 and negative 4 are, what are they called? Additive inverses. My answer is 8x. So if you can catch the inverses, there was no math to do at all. You just cancel out your opposites and you're good to go. All right, I don't need me. Okay. All right, so now let's look at the next one. Of course, what would a lesson be without fractions and decimals, right? Okay, so negative 8.5w plus 5w plus w. So I want you to look at that expression. And again, commutative property is always up for grabs. Does anybody think they might know which one they would combine first? What do you think? Halen?
5.2w plus 1w.
Yeah, because what's 5.2 plus 1? 6.2. So negative 8.5w plus 6.2w. Now you have to decide, is this same sign or different? Different. So what do? Subtract. And remember, when you're subtracting decimals, the larger absolute value goes on top. All right? So see if you can come up with your answer. See if you can come up with your answer. All right? So we're just worried about subtracting absolute values. So we get 2.3 because we didn't have to borrow. Is it positive or negative? Negative. Why is it negative? Because 8.5 was larger. All right, who got it? Who got it? All right, how are we doing? Okay, let's take a pulse. We doing okay? All right. No. All right. So we have fractions now. Okay. Now with fractions, guys, remember, I'm not going to give you super difficult fractions. We're not worried about, really hard problems. I'm worried about more. Can you recognize when to combine like terms? Okay. So let's see. Trenton, what do you think your LCD would be in the first expression? Yep, it's going to be 8. Okay. So does my first fraction need to change at all? No. So I have 3/8 b minus, what's going to be my new numerator? 6/8 b. Got to be careful. Michael, what do you think your answer is going to be?
Negative 3/8.
Whoa, why do you get a negative? Because 6 is bigger. So 3 minus 6 gives me negative 3/8. But what do I need to remember to bring down? B, my common variable. All right. Okay, so I'm going to pause here for a minute. I want you to look at the last one. I just want to see what you come up with. Just give it a shot before I explain it. I've never explained a problem like this, so if you get it wrong, it's no big deal. All right, Elizabeth, what do you think? I haven't called on her yet. What is it? Very good. Did you notice that there were 2 variables? All right, don't be mad at me. Okay, did you notice there were 2 variables? Okay, so commutative property. Now, how many of you matched them together, just mental math? Did anybody do that kind of in your head? That's okay. It's also okay to rewrite it, matching up your variables next to each other. All right. I think it's a great idea. All right. Now I can see same sign, add and keep, right? So negative 10 minus 5 is negative 15y plus 15x. Okay. This answer is perfectly acceptable for this chapter. Okay. In a chapter in the kind of distant future, I'm going to ask you to write the terms in alphabetical order. So between X and Y, which one comes first in the alphabet? X. Is 15X positive or negative? It's positive. So when I rewrite it, it's going to be positive. Now, is 15Y positive or negative? It's negative. So that's why I would say minus 15Y. I'm not changing anything. Do you see that? All I did was switch them around so they're alphabetical. All right, and that's what we call standard form. You're not going to learn a whole lot about that in this chapter, but it's coming later. So if you want to switch them around now, that's perfect. You're practicing something for the future. Okay? Let's see. This is where we left off in first hour. We do have a little bit more time. The more we get done today, the more time we have tomorrow to start on the homework. So let's just do one of these. We're going to do the harder one, though. Which one do you think is harder? Don't try to play opposites. You know the right one's harder. Okay. All right. So we're going to simplify. All right. Now we have 4 terms. We've only done 2 and 3 terms up until this point. But it's still going to be the same where we match up our like terms together and we simplify. Okay. All right, let's see who can do it. All right, which terms would you group together, like terms? So 4.2x. 4.2x. Which term would you rewrite next to 4.2x? Negative 6.5x. Okay, you can combine those together. Now, this step is optional, okay, but I think it's a good idea. Then you could bring down negative 5 plus 10, okay? 5 was negative, so you bring down a negative 5. All right, now I'm ready to combine my like terms. Do I have same sign or different with my x's? I have different. So I need to subtract my decimals. If you can do this mental math, perfect. Okay, so it's going to be 2.3. Is it positive or negative 2.3x? Negative 2.3x. And now combine your numbers. What's negative 5 plus 10?
5.
Positive 5. Does everybody see why I put a plus sign in front of the 5? Because, yes, once I combine my numbers, it's positive 5. If my signs were switched and it was negative 5, I would have wrote a minus 5. Okay? So that's why it's negative 2.3x plus 5. All right, how'd you guys do on that one? You cannot solve it. This is it. This is your final answer because 2.3x and 5 are not like terms. You cannot combine them. So that's where you have to fight. Yes. It would not be 5x. There is no x.
But it would have to be 5x.
It would have to be 5x, yes. If it was 5x, you could combine them.
I thought you could just do
Nope.
5 minus that and put the
No,
x.
you're trying to solve an equation, but there's no equal sign there. It's just an expression. So you're thinking what we're going to learn in chapter 4. Okay? Now, example 3 got messed up in your notes. They should have been side by side. Okay? In example 3, we're just getting a little more complicated with our expressions. So in example 3, we see the 4 terms, just like we just did. All right? But now we have fractions here. So which terms would you group together? Which terms would you group together? All right, to use commutative property. So everybody, let's write the second step together. All right, Mikhail, what do you think? and 1/2. Now remember, is 1/2 positive or negative? Negative. Now, how many of you could go ahead and change 1/2 to the common denominator in your head? Could you do that? If you can, go ahead and do that so you don't have to keep writing extra steps. What would you multiply 1/2 by to get to your LCD? 2. Okay, so this becomes 2/4 y. All right, you see what I did there? You don't have to necessarily show that. You could do that in your head. Now bring down the rest. Plus 12 minus 6. Okay, why was it minus 6? What?
There's no -6 on ours.
There's no minus 6 on yours?
No.
Oh my word. All right, well, put the minus 6 in there. Oh my word. Something is possessed in my notes today. I'm serious.
And the pictures down here.
I know, the pictures are all messed up. Everything's messed up. All right. Okay, look up here, guys. So now combine your like terms based on what's on the screen. Okay, combine your like terms. Can somebody raise your hand and tell me the answer? Raise your hand, and I think I've called on everybody, I think. Kyrie?
1/4 y plus 6.
1/4 y. Why would she say plus 6, not minus 6? Because 12 is bigger and it's positive, so 6 is positive. All right, so let me ask you this on the last one. Can I just combine all my coefficients together? Why not? They all have a variable. But they're not the same variable. So you can only combine the terms that have the same variable, and pay attention to the sign in front of the term. Okay, try to do that one. Okay, so what did you guys get?
8y.
Is it positive 8y? Okay, same sign, add and keep. Keep your negative. Okay, negative 8y plus 13z. Is this written in standard form? Does y come before z? Yes. So it's alphabetical already, and we are good to go. This is everything for the majority of 3.1. We've got a few things to cover tomorrow.